Greetings, detectives. Mrs. McKay here, and we're working on Clue 2 for Case 7, Shady Inequalities. And our learning target clue is I can solve a system of inequalities. And the way we're going to do that is by graphing. With systems of equations, we learned three different ways. We learned three different ways to solve a system of equations, and one was with graphing, the second one was substitution, the third was elimination. With systems of inequalities, we're just going to use graphing. All right? So, very quickly, let's just review when we graph a two-variable inequality, a linear inequality. When we have a greater than or less than sign, we always use what type of line to form that boundary line? It's a dashed line. And if it is greater than or equal to or less than or equal to, it becomes a solid line. All right? So you just want to remember that. It's kind of important because there's those three main ideas that we need to make sure that we do when we're graphing a linear inequality. One is to graph the equation of the boundary line. The second is to decide whether it's going to be solid or dashed. And the third is to choose the area, the half plane that's going to be shaded. So let's go ahead and get started and graph this system of inequalities. Now, the way that we graph a system of inequalities is we basically do it the same way we do with systems of equations. We look for an intersection. The difference is that with a system of equations, the intersection is 1 point. 1 point. But with a system of inequalities, it's going to be a whole area. Remember that it's an entire half plane that gets shaded. So we're going to graph two inequalities. We're going to see where their shadings overlap, and that's going to be our solution. All right, let's go ahead and get started. Y is less than 2x plus 2. Why don't you go ahead and graph the boundary line for y is less than 2x plus 2. So go ahead and graph that line. That's going to be your boundary line, and decide whether it's going to be dashed or solid, and go ahead and graph that line. The line, you can see how I've graphed it, and you can see that it is a dashed line. The next thing that I want to do is I want to shade the area that is the solution set for this inequality. We're doing the top one first, and it's the red one. So I can see that y is less than 2x plus 2. I can also test my point 0, 0, and I would get 0 is less than 0 plus 2. So 0 is less than 2, which that means that that's a true statement. So everything underneath the line is going to be shaded. So I'm going to just very carefully sort of do this. And I'm not making it really big because I want you to see that I'm going to do the next one in a different color. And I'm actually looking to see where my two half planes overlap. All right. Next thing I'm going to do is I need to graph my second equation on this same coordinate plane. This time I'm going to use a different color. I think I'll use light blue here. And you go ahead and graph it as well, paying attention to whether it's a solid or a dashed line, and getting your line graphed and shaded. Okay, so now I've drawn my boundary line, which is the y equals negative x minus 3, graphed negative 3, and went down 1, over 1, down 1 over, or up and back, and I connected my points, and I made it a solid line because it is a greater than or equal to, which means that the line is included in the solution set, and now I just have to shade it. So it's y is greater than, so I think it's going to be shaded above, but I'm going to double check my point 0, 0, and if I put 0 in for x and 0 in for y, I get 0 is greater than or equal to negative 3, which is a true statement, which means that the section where the 0, 0 is above this line is the solution set. So now I'm going to go ahead and shade above this line. And what I'm going to look for is I'm going to look for the places where my two graphs overlap. And you can see where it is. It's right in this area, right? So if you think about right here where they intersect, it's everything from here down and up. So from here down and up, this whole place that has the red and the blue is my solution set. And there I have graphed my system of inequalities. I found the points that satisfy both equations, that make them both be true statements. Let's do the next one. The next one says y is greater than or equal to negative 3x plus 1. So go ahead and graph that one for me. Okay, I've graphed my line, and it is the y equals negative 3x plus 1. And so I started at 1, and I went down 3 over 1, down 3 over 1, and up 3, back 1. And I've graphed my line. It's a solid line because it's y is greater than or equal to. And so that means that it includes the line. And y is greater than that, so that means that it's going to be above the line. So my shaded area is going to be right here, going this way. Now it's time to go ahead and graph the second line. Now I'm going to go ahead and do this with you because it's going to be a little tricky. So I'm going to change my color to green, and I'm going to start by graphing my y-intercept, which happens to be 2, which is right there. All right? And then I'm going to go the same slope, down 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. You can see that these lines are very close to each other. 1, 2, 3. All right, now I'm going to try to graph this line. And now I've gotten my line drawn. Again, it's a solid line. Notice how close it is to the orange line. They are not the same line, but there's something very special about these two lines. What is it? That's right. They are parallel lines. They have the same slope, don't they? Negative 3 and negative 3. Let's go ahead and finish graphing this. Remember that parallel lines, when they are graphed and we're looking for an intersection where the two lines intersect in a system of equations, we'll never get a solution. But let's see if we can get a solution when we're talking about inequalities. So this second inequality that I've just graphed the boundary line for is y is less than or equal to negative 3x plus 2. I need to go ahead and do my shading. So this time it is less than, y is less than, which means that it's going to go underneath the line. So it goes this way. This whole area here, all the way down. And can you see the place where the two overlap? It's this little narrow strip between the two, isn't it? Let's maybe do that in purple so you can see it. It's this area right here. Everything in between these two. So that is the area, that slim, narrow strip where the two overlap. Everything else is not in common, but that one area in between those two lines is where the solution set is. All right, so that is solving systems of inequations or systems of inequalities. So let's just remember what you have to do. You have to first graph each inequality, making sure to shade the half plane of each one. Then you find where the two graphs overlap, and that is your solution set. Important things to remember: parallel lines won't ever intersect, but you may have those intersections, the inequalities might intersect because they might cross over each other. And then you have to always pay attention to the inequality and shade the appropriate half plane. Last thing to do is to write yourself a key idea, and I'll see you in class.